Welcome to Physicists in the Wild. My name is Aggie Branczyk. In this series, I chat with physicists who pursued careers outside of academia. In this first episode, I'm delighted to welcome Rohan Dalton, who did his PhD at the University of Queensland in Brisbane, Australia, in experimental quantum optics, and who now works as a data engineer in the fintech industry in New York City.
So my official job title is software engineer. I work for basically a hedge fund over in the US now. Software engineering to focus on data.
How did you end up doing a PhD?
It started all really on my first day of year 12. And my year 12 physics teacher was this guy, Graham George, who was very passionate about physics and about teaching physics. And he gave us this big speech about, sort of physics isn't a subject, it's a noble endeavor, and how basically if you understand physics, you can understand anything. And that made me much nerdier about physics than any of my other subjects. At that point, though, I wanted to be a psychiatrist. And then actually, when I got to university and started doing biology, and realized that I didn't like biology at all because it was just basically just stamp collecting. And as you know, I was very lazy when I was in undergrad and would not go to most of my lectures or any of my lectures. And at least with physics, it didn't matter as much. I understood the concept. Having not been to the lectures wasn't as big of a detriment, right? Like I remember at least a couple of exams, there'd be a question and I'd sort of spend 2 pages deriving some equation and then getting the equation like, that was in the lecture. If I'd been paying more attention, I could have just started from this point. But it didn't matter because, fundamentally, if you understood it, you could get to where you needed to go. Whereas with biology exams, like you either knew it or you didn't know, right? It was multiple choice. It was just, what is this thing? I don't know. So I discovered pretty quickly that I did not like biology and it wasn't a good fit for how lazy I was. So I decided to stick with physics. And then just seeing if you wanted to be a physicist, that was just the thing that you did, right? Like you did your undergraduate degree, you got a PhD in physics, you became a postdoc, and I didn't think too hard about it. It just seemed like, well, if I'm going to be a physicist and that's what I like doing, then I should just go and that's how you become a physicist.
How is it that you got into the job that you're doing now?
The hands-on sort of side of things and the doing research side of things was always something that I enjoyed a lot. The question sort of really came, more towards the end when I was thinking about, what I wanted to do next. And thinking, so talking to people and thinking about it, and sort of that, it felt to me like the more you progressed in physics, the less and less physics you actually do, right? It becomes much more about, grants, justifying grants you've already been given, and just a lot more sort of administration. So I was thinking about what I wanted to do next, and I didn't know what it was. And I also didn't really think that there were many options. I was thinking very, very specifically in this term of, single photon quantum computing experiments. I'm like, I'm really good at, beam steering and setting up experiments and quantum tomography and whatever. And these are not skills that are important to anyone outside of experimental physics, right? Like no one has ever asked me in the subsequent time to, perform quantum tomography. So I was like, oh man, what do I do with these skills, right? No one else wants, people who can do this. I was out in the valley one night and I ran into an old coworker of mine. She was working at the time for a hedge fund in Brisbane, and said, well, why don't you come down and have an interview with us? So I went down and interviewed, and I was like, yes, this is it, because the skills that they were after were the things that I hadn't really been thinking about so much, where it was very much about like programming, some analysis, data modeling, but like problem solving. How do you look at this data, figure, and I was like, I can do other things that I didn't really think about too hard, because in my head, like, everyone does this, right? Like, this is just a very basic skill that everyone has. I'm like, oh no, it's not a very basic skill everyone has. It's a skill that most physicists have, because everyone in physics does these things. But it's apparently a very hard thing to hire for outside. And they said, look, we really like you. We would like to give you a job because you can do all of these things that we're having trouble, trying to find people to do. And I'm like, great, I will come and work for you.
So can you tell us a little bit about what your day-to-day is like?
I think there's a lot of variation, sort of very much depending on sort of the project. It's largely, very much by and large, still problem solving, which is, something that I really enjoy. It's just, now I do it. There's less mirrors and less beam splitters, and it's all keyboards and monitors. But the general problems around things like, so there's the data ingestion is a big part of that. So whether you're connecting to some like REST API, gRPC server, an external database, FTP site, SFTP, web scraping, whatever that mechanism is, then around ingestion, storage, quality control, making sure that things exist, that they look right. So there's like building out all of those tools to basically make it easier for people to access all the different types of data that we provide in sort of unified, uniform ways. And then there's almost like DevOps style things. So monitoring Kubernetes clusters and monitoring the health of of REST API services, and like making sure the CI/CD pipelines are all working properly. I've had to learn a lot of things about sort of the stock market and things like futures and options and interest rate swaps and all this kind of stuff. That's the only part that's very specific to about being finance, is the fact that these are financial data and financial vendors, but the building of the pipelines and the building of APIs and the databases and the monitoring, it's all very data engineering.
So what would you say are your most favorite and least favorite aspects of your job?
My most favorite aspect is definitely like building things and building cool things that people use. It's always nice, I think, when you start like a brand new sort of project and get to sort of sit down and think about what the problem is that you're trying to solve, and figure out which technologies you're going to use and how you're going to build this thing and whatever. And that's definitely the best part. And probably the worst part is the exact opposite. It's feeling like legacy code and just dreadful decisions that were made by people who aren't even at the company anymore.
Do you find that you work with a lot of physicists?
A lot. More on the quant side than on the software engineering side. But yeah, quantitative finance is absolutely full of ex-physicists.
Let's say there is a physics PhD student who's interested in transitioning into that field. What skills should this person learn, or is that even the right thing to ask?
Ooh, it is a good question. I would say that they're going to want to have a sort of decent background, probably in Python, tools like pandas, NumPy, for doing actual analysis and creating plots. If you are doing data analysis at the moment for experiments or whatever, and you're doing it in Python, you are probably off to a good start. There are other skills that are nice. There are teams out there that are working on machine learning type modeling, but that's not everyone. You don't have to know how to use TensorFlow or Keras or whatever. People out there that use R still. It's not nearly as prevalent as it used to be, but you might need to know it at some point. But I would say that regardless of what role you're going to go into, just having like a solid Python data analysis skills are going to be a universal. You're going to want pretty much any sort of quantitative finance role that you go into.
Do you think boot camps or online courses are a good way to learn those skills?
I think it depends very much on the context. So I would say if you are if you're a physicist and you want to brush up or get a bit better at that type of skill, probably yes. Because that, like, when someone looks at your resume, they're going to say, oh, well, this person has a, a background in physics. They got a PhD in physics, and they've done this data boot camp. And great. If it's just the data boot camp and you're coming, that's all that you've got, it's probably not going to get you a phone call.
I tend to think of them as signaling to a potential employer that you have the capacity to learn this stuff. And as long as you can communicate that you know how to learn new things, then on the job, I guess, is where you're going to.
Yeah, I think that's a huge skill that not everyone has. My background was in physics and I did everything in MATLAB, right? So I have basically had to learn, and I use zero MATLAB at any moment, right? So everything I know, I have to learn. I had to learn, right? So this is what all the books behind me. Like I have taught myself, everything about databases and Python and different programming languages and different technologies. So think Docker, Kubernetes, but I've also been in roles where people have had to learn new things. I'm like on the job, they're like, oh, we're gonna learn this. I'm like, dude, what is wrong with you? We are paying you to learn it. Like, just suck it up and learn it. The book I would recommend to people, probably more than anything else, is Fluent Python. A second edition of it actually just came out, and I like it so much that I bought the second edition, even though I already had the first edition. So I feel like there's a lot of books out there on sort of, Python and on data analysis that, not that they're bad, but they don't go into the depth of a lot of that, something like Fluent Python does. It's the one that's really, really made me understand how a lot of the inner workings of the language and how to do some very cool things that I normally discourage people from doing, but that are awesome in certain situations. And then the other one that I more for the data side of things is this one, Designing Data-Intensive Applications by Martin Kretman. It's very, there's no sort of real code in it or anything, and just sort of lots of diagrams talking about very subtle ways that things can go wrong. But yeah, if you want to get into specifically around building applications that ingest data and store data, that is definitely the one to go with. Yeah, they would be my two recommendations.
What about how you have to dress to the office?
I just jeans and t-shirt, jeans and a hoodie.
Okay.
There are people who come into the office in shorts. I don't dress quite that casually, but yeah, it's not fancy at all.
If I was a young physics PhD student right now, thinking about what I want to do with my life, what advice would you give me?
Even if you do not think that you are going to end up using your PhD, right? It doesn't mean that you have not acquired a huge number of skills over those, sort of many years that you are going to be able to take to something else. If you're at the end of it, I would say, look, whatever, just finish it, figure out what you want to do and go and do that. If you're at the start and you're already thinking to yourself, if this is not where I want to end up, then just stop now and go and do the thing that you really want to be doing.
Thank you so much, Rohan. It's been a pleasure talking to you. I love that you were my first guest, and I'm sure
I'm very honored, Aggie.
A lot of value from this. Thanks so much.